Hello everyone, I am Gagan Laddha and today we are going to discuss a new subject, that is fluid mechanics. Now what actually is a fluid mechanics? Let us first discuss this word mechanics. What is a mechanics? As we all know that mechanics is a branch of science which deals with forces and its effect on physical properties of the substance. The branch of science which deals with forces and its effect on physical properties of the substance is called as mechanics. Okay, when this mechanics is applied to rigid body, this becomes engineering mechanics. When this mechanics is applied to flexible body, this becomes mechanics of solids, what we commonly known as strength of materials. And when this mechanics is applied to fluid, this becomes fluid mechanics, the subject which we are going to deal now. So this is actually is the fluid mechanics, the mechanics which is applied to the fluid. That means what we are going to study in this subject is the forces and effect on physical properties of the fluid. Now coming to the second word, that is fluid. Now what actually is a fluid? Fluids are the substances which can flow. To define it in a very simple way, the substance which can flow on the application of shear stress is known as fluid. And to make this the concept of fluid more clear, let us differentiate this with respect to solid. What happens in solid and what is the difference between the solid and the fluid? Suppose we are having a solid and we are applying a shear stress on this solid, and on the other hand we are having a fluid and we are applying a shear stress on this fluid. Now what will be the difference between these two? In solid, as we know that when we apply shear stress, this solid body will get distort or will get deform, suppose by an amount phi, and this phi is nothing but shear strain. We have already seen this in the subject of mechanics of solids. Now what will happen in the fluid, and once this stress is removed from the solid body, if this shear stress tau is removed from the solid body, this body either fully or partly regain its original shape. This is the property of solid. Okay, now what actually happens in the fluid? Suppose we are having an element at this particular point and we are applying a shear force on this fluid. What will happen? This element will continuously deform or continuously change its place like this, and it will never regain its original shape. This is the basic difference between the solid and the fluid, that the solid can resist the shear force under static condition. Fluid cannot resist the shear force under static condition. It can resist the shear force only under dynamic condition. First thing. Second thing, as I told you, if a shear stress or shear force is removed from the solid body, the solid will regain its original shape. The fluid do not regain its original shape on removal of shear stress or shear force. So we can call the fluid as a zero memory substance. Solid has a memory that it regains its original shape. Fluid has no memory. Once it gets deforms, it never regains its original shape. Second thing. Third thing, the difference between the solid and the fluid we are discussing. In solid, we have discussed that shear stress is directly proportional to shear strain. Okay, the angle by which the body distorts, that angle is nothing but the shear strain. And what we have seen is shear stress is directly proportional to shear strain, and the ratio of the shear stress to shear strain is G, which is modulus of rigidity. Okay, because in solid the shear strain was fixed for any particular amount of stress or any particular amount of shear load, shear force, the shear stress was fixed. But this is not the case in the liquid. What will happen in the liquid? In liquid, this angle phi, what we call as shear strain, this is continuously changing because the element is continuously changing its position. Getting yes or not? So in this particular case, in liquid, the shear stress is directly proportional to rate of shear strain, not just the shear strain, because the shear strain is continuously changing in this. In this, the shear strain was fixed, that means shear stress was proportional to shear strain. In this, shear strain is continuously changing with respect to time. Thus, in fluid, the shear stress is directly proportional to rate of shear strain, not just the shear strain. Getting this or not? So, when you have understood this, when you have understood the basic difference between the solid and the fluid, now moving further, let's suppose we have any layer of fluid the width is suppose B, and at the top we are having a plate, and this plate is having a velocity suppose u. Getting this? Okay, the fluid in the immediate vicinity of this fixed body, this will have a zero velocity, and the fluid which is in contact with this particular plate will have the velocity of u. Getting this? And let us suppose the variation, suppose we are considering as a linear variation, that means velocity is changing with respect to y-axis linearly. I think this figure is clear. Now what will happen, suppose after any particular point, after any particular time, suppose dt, what will be the position? Suppose this angle is d theta, this angle is suppose d theta, this distance is b. Okay, so what will be this distance? Arc is equal to what? Angle into radius. So this is nothing but b into dt. Sorry, b into d theta. This is nothing but b into d theta. First thing. Second thing, this plate is moving with a velocity u. Okay, and after time dt, this particular element is covering this much distance, b into d theta. Okay, so this distance is also equal to velocity into time, that is u into dt. Getting this particular distance, b into d theta, and also equal to u into dt. U is the velocity and dt is the time after which we are watching that particular element. Getting this? And variation we are considering as linear. Now what will happen? This b into d theta is nothing but u into dt, or you can say d theta by dt is equal to u by d. What is this d theta by dt? This is nothing but rate of shear strain. If this angle is theta, then this is nothing but rate of shear strain, and this is equal to u by b. Getting this or not? At this particular point velocity is 0, at this particular point velocity is u, at this particular point y coordinate is 0, at this particular point y coordinate is b. So you can also write it as du by dy. Change in velocity to change in distance. Okay, so what we are getting from here, the rate of shear strain is equal to du by dy. One thing we have seen, that shear stress is directly proportional to rate of shear strain, or you can say tau is directly proportional to du by dy. If you remove the proportionality sign, you will get what? Tau is equal to mu into du by dy, where mu is a constant, and this mu is nothing but coefficient of viscosity, or you can simply call it as viscosity, or you can call it as dynamic viscosity. Okay, so this is actually the viscosity. So what is viscosity? Viscosity is the property of the fluid. Which property of the fluid? Now what is this mu? Mu is equal to tau upon du by dy. Getting this or not? इसका मतलब क्या हुआ? विस्कोसिटी जितनी ज़्यादा होगी, रेट ऑफ शेयर स्ट्रेन उतनी ही कम होगी. That means वो बॉडी में उतना ही ज़्यादा रेजिस्टेंस हो रहा है अगेंस्ट फ्लो. Getting this on? Let us consider, suppose there are two fluids, water and honey. ओके वाटर जो है वो बहुत फास्ट फ्लो होगा, उसका जो रेट ऑफ शेयर स्ट्रेन है वो ज़्यादा होगा. हनी अगर फ्लो होता है तो उसकी रेट ऑफ शेयर स्ट्रेन जो है वो कम होगी, फ्लो जो होगा वो स्लो होगा एज कम्पेयर टू वाटर. इसका मतलब क्या हुआ, रेट ऑफ शेयर स्ट्रेन कम है, डेट मीन्स विस्कोसिटी उसकी उतनी ही ज़्यादा है. So how can you define viscosity? What actually is the viscosity? Viscosity is the property of the fluid which offers resistance to the flow of fluid. Fluid की वो property जो fluid के flow में resistance offer करे, that property is nothing but viscosity. Getting this or not? So I think the concept of this viscosity is clear. Okay. Now what should be the unit and dimension formula for this viscosity? Dimension formula, mu is equal to what? Tau upon du by dy. Tau is nothing but force per unit area, that is F upon L square. What is this du by dy? This is meter per second upon meter, that is 1 by t per second. Okay. Further, this F upon L square, this can be further written as ml minus 1 t minus 2 upon 1 by 2 1 by t. So this will be equal to ml minus 1 t minus 1. This is the dimensional formula for viscosity. First thing, what is the unit of viscosity? What will be unit of viscosity? Tau is, mu is equal to what? Tau upon du by dy. Tau is shear stress, okay, which is force per unit area, that is Newton per meter square. Du by dy, velocity is meter per second meter, so this will be equal to Newton second per meter square, or you can call it as Pascal second. So this is the unit for viscosity, Pascal second. Okay. Further, Newton second per meter square, this can be written as kg into meter per second square. Newton can be written as what? Kg meter per second square into second upon meter square. So this will be kg per meter per second. Okay. Further, 1 Newton can be written as 10 raised power 5 dynes. Okay. In terms of dyne per centimeter square, we are converting this. So Newton second per meter square. So what will be Newton second per meter square? This can be further written as Newton is 10 raised power 5 dynes second. Meter square, if converted to centimeter square, this will be 10 raised power 4 centimeter square. Okay, or you can say this is equal to 10 dyne second per centimeter square. Okay, and 1 dyne second per centimeter square is nothing but 1 poise. Therefore, 1 Newton second per meter square, this is equal to 10 poise, or you can say 1 poise is equal to 0.1 Newton second per meter square, or 0.1 Pascal second. So here is an important conversion, because generally the unit of viscosity is given in poise. So if it is given in poise, this 1 poise will be equal to 0.1 Newton second per meter square. Getting this or not? Now coming back to the formula, what we have seen, tau is equal to what? Mu into du by dy, and this we have got from tau is directly proportional to du by dy. And the fluid which follows this particular law is called as Newtonian fluid, and this particular law is nothing but Newton's law of viscosity. This is Newton's law of viscosity. Getting this? So this is Newton's law of viscosity, and the fluid which obeys Newton's law of viscosity is nothing but the Newtonian fluid. And fluid which do not obey Newton's law of viscosity is known as non-Newtonian fluid. Getting this or not? Okay. Now coming to the causes of viscosity. what actually are the causes of viscosity? So basically there are two causes of viscosity. First is intermolecular force of cohesion, and second cause is molecular momentum exchange. Okay, what actually is the force of cohesion? The force which is acting between two molecules of the same body, two molecules of the same nature. That force is actually the intermolecular force of cohesion. So what will happen in the intermolecular, basically solids and liquids are having solids and liquid molecules are having this intermolecular force of cohesion which binds that molecules together. Okay, in gases intermolecular force of cohesion is very less as compared to solids and liquids. So what will happen when intermolecular force of cohesion is acting? Suppose this is our liquid layer, these are suppose two molecules. Okay, if I am, and this are joined with the help of this force, intermolecular force of cohesion. Okay, and if I am applying a force on this particular molecule, अगर ऊपर के molecule में force लग रहा है, so this molecule will try to resist the motion of the second molecule. Getting this or not? So this will cause viscosity. This causes the viscosity. Viscosity is actually the resistance to the motion of the fluid. Okay, so this is the first cause, which is predominant in liquids. Liquids में जो basically जो cause रहता है viscosity का, that is intermolecular force of cohesion. Okay, second is molecular momentum exchange. Molecular momentum exchange, as we know, when suppose in gases the molecules are moving, and when the molecules are moving they collide with each other and they exchanges their momentum. Okay, because of that उसके जो motion है वो resist होते हैं. That is nothing but molecular momentum exchange. So basically liquids में जो viscosity होता है that is because of this intermolecular force of cohesion, और gases में जो viscosity होते हैं that is because of this molecular momentum exchange. So these are basically two causes of viscosity. Now coming to a very important point, if we are increasing the temperature of a liquid, what will happen to the viscosity? And if we are increasing the temperature of the gas, what will happen to the viscosity? Let us understand this thing very carefully. अगर हम liquid का temperature बढ़ाते हैं, what will happen when the temperature of liquid rises? The force of cohesion drops. Force of cohesion decreases. अगर हम liquid का temperature increase करते हैं तो उसका cohesive force जो है वो decrease होता है, और cohesive force अगर decrease हो रहा है that means उसकी viscosity भी क्या होगी? Decrease होगी. Getting this or not? तो liquid के लिए if I am increasing the temperature of the liquid, the viscosity decreases. What about gases? अगर मैं गैस का टेम्परेचर इंक्रीज कर रहा हूं, बेसिकली गैस के विस्कोसिटी का कारण क्या है? दैट इज मॉलिक्यूलर मोमेंटम एक्सचेंज. गेटिंग दिस और नॉट? अगर मैं गैस का टेम्परेचर इंक्रीज कर रहा हूं तो क्या होगा? दिस मॉलिक्यूलर मोमेंटम एक्सचेंज विल इंक्रीज. मॉलिक्यूल्स विल ट्राई टू मूव विद अ फास्टर रेट, फास्टर वेलोसिटी. ओके, तो मॉलिक्यूलर मोमेंटम जो है वो और इंक्रीज हो जाएगा. मॉलिक्यूलर मोमेंटम इंक्रीज हो रहा है, दैट मीन्स विस्कोसिटी भी क्या होगी? उसकी इंक्रीज होगी. Okay, so in gases if I am increasing the temperature, viscosity increases. In liquids if I am increasing the temperature, viscosity decreases. Okay, so here is a very important note. In liquids intermolecular cohesion is the predominant cause of viscosity. Therefore since cohesion decreases with temperature, the liquid viscosity does likewise. In gases cohesive force is very small and viscosity is dictated by molecular momentum exchange. As random molecular motion increases with increase in temperature, viscosity also increases. Now let us solve one question. A cylindrical shaft of 100 mm diameter rotates about a vertical axis inside a fixed cylindrical tube of length 2 meter and 106 mm internal diameter. If the space between the tube and shaft is filled by a lubricant of dynamic viscosity 2 poise, the shaft is rotated at a speed of 240 rpm. Assume linear velocity variation across the gap. The shear stress on the shaft will be. Okay, so we have this question. We are having a shaft which is rotating inside a bearing. Okay, and the lubricant is filled between this gap. Getting this or not? And the viscosity of that lubricant given mu is equal to 0.2 poise. and the variation we can assume is linear, like this. Linear variation in velocity. Okay, and the shaft is rotated, n is given as 240 rpm. Speed of shaft is given as 240 rpm. Now we have to calculate the first thing, the shear stress on the shaft in Pascal. Okay, now what actually is the shear stress? Tau will be equal to what? Tau is equal to what? Mu into du by dy. Okay, or you can say mu into v upon y. What is v? V is the velocity, linear velocity at the circumference of the shaft. Okay, this shaft is actually rotating. This is actually rotating with a speed 240 rpm. Okay, so there will be some linear velocity at this particular point. Okay, that how can we calculate that linear velocity? V is equal to what? Pi dn by 60. Okay, so from here we can calculate the linear velocity at this particular point. Okay, this is a stationary, that means the velocity here is 0 and variation is linear as given in the question. Getting this or not? Okay, so this shear stress tau will be is nothing but mu into v upon y. Okay, so further just put the values. Mu is given as 0.2 poise and 1 poise is 0.1 Newton second per meter square into velocity. Now let us calculate the velocity. Pi dn by 60. So this will be equal to pi into d is how much? 0.1 into n is 240 by 60. So from here we can get the velocity. The value of this velocity is nothing but 1.26 meter per second. Getting this or not? Just put the value. This will be equal to pi v into y. V is 1.26 divided by y. Y is the gap between the shaft and the bearing. Okay, and what is this gap? This total is 106 mm. This is 100 mm. The total gap is 6 mm. Okay, so gap at one side is nothing but 3 mm. Getting this or not? So this will be equal to 3 mm. अगर मीटर में करें तो 10 to the power minus 3. Getting this? So from here this shear stress tau will be equal to 83.78 Newton per meter square, or answer is C, 83.8 Newton per meter square. This is the first part of the question. Getting this or not? Simple है? Okay. Second part में क्या पूछ रहा है? The power required to overcome the viscous resistance in watt is. Okay, so how much power is actually required to overcome the viscous resistance? Okay, viscous resistance किसके कारण है? Obviously because of the shear force. Viscosity के कारण, viscosity किस कारण से है? Because of the shear stress. Okay, so उसके कारण क्या लगेगा? Viscous resistance लगेगा. Okay, तो उस viscous resistance को overcome करने में कितना torque हमको लगेगा ये बताना है. कितना पावर लगेगा ये बताना है, सॉरी. ओके, एंड हाउ कैन वी कैलकुलेट पावर? पावर P इज नथिंग बट 2 पाई NT बाय 60. ओके, और T हम निकाल सकते हैं. व्हाट एक्चुअली इज T? T इज नथिंग बट फोर्स इनटू रेडियस. ओके, हाउ मच फोर्स इज एक्टिंग एट दिस पर्टिकुलर पॉइंट एट द सर्कमफ्रेंस ऑफ द शाफ्ट? कितना फोर्स एक्ट कर रहा है? फोर्स इज नथिंग बट टाउ इनटू एरिया. ओके, टाउ की वैल्यू हमारे पास है इन न्यूटन पर मीटर स्क्वायर. Okay, what will be area? Area is nothing but the surface area of this particular shaft. Getting this? Okay, so this will be equal to tau into surface area, total surface area of this cylindrical shaft, which is equal to pi dl. Okay, now just put all the values. This F will be equal to 83.78 into pi into diameter is 0.1 meter into length is also given as, length of the shaft is given as 2 meter. Okay, just put the value. You will get this force as 52.64 Newton. First thing. Okay, so from here we can get the value of torque, which is equal to F into radius or F into d by 2. So this will be equal to 52.64 into radius is 0.05 meter. 100 mm 0.1 meter or 0.05, radius is 0.05 meter. Okay, so this will be equal to 2.63 Newton meter. Okay, so we have got the value of resisting torque. Resisting torque mil gaya. Now just put all the values in power. So this power will be equal to 2 pi, n is 240 rpm into T is 2.63 divided by 60. So from here you will get the value of power as 66.15 kilowatt. That's it. So answer is B.